This is just a review of all the ways to solve quadratic. So you guys actually know how to do all of this, so I'm going to go quickly through it. For the zero product property, first we need to set this function to 0. Okay, and then we need a factor. Some of you may notice offhand that this you have two perfect squares here. So then you could try to see if you add those together, if that would add to the middle term. If you didn't know to do that, then we would have what two numbers multiply to AC. So you have 25 times 16, which is 400, and it needs to add to a negative 40, so that would be 20 times 20. So then we would get 25x squared minus 20x, that's how we're splitting the middle, minus 20x plus 16 equals 0. Factor out a 5x here, and you're left with 5x minus 4. Factor out a 4 here, a negative 4, and a positive 5x minus 4. So then you get 5x minus 4 times a quantity, 5x minus 4. So then for this one, it's just x equals 4/5. All right, for the next one, the square root method, you're solving by extracting the roots, and it's really a shortcut method for the difference of squares. So you need to be careful, because when you take the square root of both sides, you do need to remember that 3z minus 2 equals not just 2, but it also equals negative 2. Okay, so there's two possible answers there. Once you do this, then you solve. So we get 3z equals 4, 3z equals, when we add, you get 0. So then z is 4/3 and 0. Okay. For completing the square, what you want to do here is we're going to move the 1 over to the other side, so you get 2x squared minus 3x plus some number is going to equal positive 1 plus some number. We're going to factor that 2 out, so we get 2x squared minus 3 halves x plus some number. And now we can use this part to complete the square. So notice I have the 2 on there still. So we get x minus half of 3 halves is going to be 3/4. But when you square this, you square the top and the bottom. So that's going to be 9/16. But now we need to distribute the 2. 2 times x squared is 2x squared. 2 times negative 3 halves is minus 3x. 2 times 9/16 is 9/8. So we're actually adding 9/8 to both sides. And this is 8/8 plus 9/8, so that's going to be 17/8. And so this equals 17/8 here. We're going to divide both sides by 2 to remove this 2. So you get x minus 3/4 squared equals, when we divide by 2, we're really just multiplying the bottom by 2, so that's 17/16. Take the square root of both sides, so then you're left with x minus 3/4 equals, remember, anytime that you're solving by taking the square root, you need to make sure that you're including both the positive and negative value. So root 17 square root of 16 is 4. So then, and you want to make sure to do both, because this is a shortcut method for difference of squares. And then we just add 3/4 to both sides. And then because it's a root, we cannot combine the 3 and the root 17, so we can just leave it like this. Right, for quadratic formula, we have the opposite of b, plus or minus the square root of b squared minus 4ac. All of this is over 2a, not just the root part. This opposite of b is also over 2a. All right, in order to do this, though, we have to first identify what a, b, and c are, and in order to do that, it has to be in standard form. So here we have 2x squared, and then plus 2x minus 1 equals 0. So here's my a, b, c. So we have the opposite of b, plus or minus the square root of b squared minus 4 times a times c. All of this is all over 2 times a. So then that's negative 2 plus or minus a square root. There's two negatives here. So this becomes really 4 plus 8 over 4. So that's negative 2 plus or minus root 12 over 4. But root 12 is 2 root 3 over 4. We can factor out a 2. So negative 1 plus or minus root 3 over 4. And then the 2/4 reduces to 1/2. So this is really negative 1 plus or minus root 3 all over 2. For this one, you're more than welcome to use A, B, and C. What's nice though is if you were purely solving, you can actually multiply. So even though it would do a vertical stretch to your quadratic equation, anytime you're changing vertically, remember that doesn't change your intercepts. So what you can do here is we have a 4, a 4, and a 2. If we multiply all of this by 4, okay, then we're going to get 3x squared minus x minus 2 equals 0, and then the quadratic formula is so much easier to use in comparison. So we have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so that's going to be 1 plus or minus the square root of 1. I have 2 negatives, so that's plus 4 times 3 times 2 is 24 over 6. So that's 1 plus or minus. This is root 25. Now you need to be careful here because we can actually evaluate this. This is 1 plus 5 over 6. And it's also 1 minus 5 over 6. So 1 plus 5 over 6 is 6 over 6. So x equals 1. 1 minus 5 is negative 4 over 6. So that's negative 2/3. And then for the last one is using your calculator to solve. So you're going to go to y equals, and we're going to type in x squared plus the square root of 2. Be careful here. This root 2 is in front of the x. Notice how the symbol stops short of the x. So here you need to arrow right and then press x and then minus 2. Zoom 6. We're looking for the 2 intercepts. Okay, so we can see the 2 intercepts. We're going to call those zeros. So the first one, we have 1, 2, 3. It looks like it's in between negative 3 and negative 2. So left bound negative 3, right bound negative 2. And then our first 0 is approximately negative 2.29. Your calculator may give you a lot more numbers, just so you're aware. I have my mode, so it actually rounds for me to 2 decimal places. So if you had more values, that is more likely than it actually stopping at the hundredths place. So, so I'm just rounding, and my calculator is doing the rounding for me. So my other 0 is in between 0 and 2. So 0, enter, 2, enter. I guess it's around 1 specifically. It's 0.87, so approximately 0.87. Okay. Make sure that if you are unsure how to do any of these solving methods, you either need to go see me or go to the Lit Lab and make sure that you feel comfortable solving a quadratic using any of these.